Hello and welcome to the live broadcast of Rocket Lab's 5th Electron launch, the R3D2 mission for DARPA. We are currently sitting at T-minus 11 minutes from target liftoff. The weather is looking green and we are ready to launch this mission to orbit. My name is Max Muncy. I'm part of the mission operations team here at Rocket Lab, and I am coming to you live from Mission Control here in Auckland, and I'm so glad you could join us to watch yet another Electron launch. The spacecraft on board Electron today is called R3D2, and this stands for Radio Frequency Risk Reduction Deployment Demonstration. This mission intends to space qualify a prototype reflect array antenna to improve radio communications in small spacecraft. So we have a short video from DARPA which explains more about the payload and its mission.
R3D2 is the RF risk reduction deployment demonstration. And what we're doing on this mission primarily is demonstrating a new high compaction ratio deployable antenna. So an antenna has a lot of different uses for DoD. One example is communication. The antenna and the power you have in the satellite dictates what size of antenna you need on the ground to receive it. So the bigger the antenna you can have in space, the smaller the one can be on the ground. Fitting that very big antenna into a smaller satellite makes the satellite less expensive and allows us to leverage different types of launch vehicles that maybe we wouldn't be able to use for bigger satellites. So once it reaches orbit, the first thing we try to do is gain communication with the satellite. Once we've done that, we'll deploy our solar arrays, and then the small container on the top of the satellite is where the antenna is housed. So it has 4 different carbon fiber deployment mechanisms that will go out on each corner. And then it has a pantograph, which is a shape that kind of looks like an accordion, around the outside that will expand. And then we will begin to see how flat the antenna is. We'll do some assessments from the ground to see what it might be able to transmit. And what's really making the antenna work is the copper etchings on top of the Kapton. So Kapton looks a lot like cellophane you might have in an Easter basket. And so it's a great place to hold the copper, which is what is reflecting the energy. And it's just set into the Kapton. And so when electromagnetic radiation hits the antenna, it acts like a parabola and focuses that energy instead of acting like a flat plate.
10, 9, 8, 7, 6, 5, 4, 3, 2.
Stage 1 propulsion is nominal.
Beginning pitch over.
As you just saw, we have had successful liftoff of the R3D2 mission on Electron. Coming up soon, Electron will go through a series of mission milestones in quick succession, including main engine cutoff, or MECO, where the 9 Rutherford engines on Electron's first stage will shut down. Shortly after this, we'll see Stage 1 separation, followed by ignition of the vacuum-optimized Rutherford engine on Electron's second stage. Following second stage ignition, Electron's fairing will separate, revealing the payload in preparation for deployment approximately 50 minutes from now.
One minute remaining.
Stage 1 propulsion still nominal.
AOS Chatham Station.
Power pack CO2 successful.
Engines throttle down, 20 seconds remaining.
Entering burnout detect mode.
Stage 1 MECO.
Stage suppression succeeded. Mission on stage 2 propulsion is nominal.
Right down the center line.
Fairing jettison.
And there you have it. Confirmation that Electron's main engines have shut down as planned. We've had stage 1 separation and the stage 2 engine has successfully ignited. Electron is now carrying on to orbit.
Speed is 3 kilometers per second. Altitude is 150 kilometers.
Stage 2 propulsion still nominal.
Getting throttle down. Guidance is nominal.
One of the unique features about Electron is its Rutherford engine. These brushless DC motor engines are powered by lithium polymer batteries. In a few moments, we'll be performing a battery hot swap where we switch from 2 depleted batteries to a third fully charged battery. Shortly, we'll see the depleted batteries jettisoned to allow for a more efficient flight to orbit.
Vehicles transited successfully to safe gate.
HV battery hot swap. HV battery eject.
Seconds remaining. 1 minute remaining.
Stage 2 propulsion still nominal. Entering stage 2 burnout detect mode.
Seconds remaining. Ten seconds. Successful transfer orbit.
Interstage separation.
All right, you heard the call. The kick stage has now separated from Electron's second stage. Approximately 40 minutes from now, the Curie engine on the kick stage will ignite and circularize to a 425-kilometer orbit for payload deployment. Because we won't be receiving video of today's payload deploy, this animation shows what the deployment of the R3D2 spacecraft will look like. Once the kick stage reaches a precisely planned point in orbit, the R3D2 payload will separate from the kick stage approximately 40 minutes from now. At this point, the mission will be complete. Here at Rocket Lab, we don't just go to orbit, we deploy satellites with exquisite accuracy thanks to this kick stage. The small but agile upper stage is equipped with cold gas thrusters that enable precision pointing. It means we can orient the kick stage to just the right position, then deploy our customer satellites to exactly the right orbit.